Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. As I showed in a previous video and a previous lesson, in green here I have this function here, which is a quadratic function, second degree, where we can tell just by looking where the vertex of the parabola is. And the vertex, of course, is the lowest point if it opens up like this, or the highest point if it gets flipped down. But that's sort of the starting point. And on our XY chart, notice how we're going to be just squaring it. This is called the parent function. It's a U shape. Everything's all symmetrical and balanced. So once we know where the vertex is, we're going to go over 1 up 1, or over 2 up 4, or over 3 up 9, and then in the opposite direction. So the key is finding the vertex, and we have to put equations in this form. Let's look at our first example. So we're going to use a technique called completing the square. And the idea is that we take these first two terms, the squared term and the x term, and we keep them together. We move this constant term out because we're going to need to fit something in between. Okay? Now the idea is that this thing that I put right here in the third place has to complete the square. We're looking to make a perfect square trinomial. Now, hopefully you've had enough algebra where you can figure this out. The idea is that we can take half of the middle term, and there's a reason for that, which I won't get into here. Half of the middle term is 3x, but drop the x. Just think of it as a 3 and then double it, or excuse me, square it. So 3 squared is 9. Alright, so if I have x squared minus 6x, I need a 9 right there to be able to say that I have a perfect square trinomial that can be factored like this. Okay, now when I add 9, I need to subtract 9 over here. Alright? In other words, I can't just add anything over to this right side. If I add it here, then I need to subtract it here because I have to keep this side of the equation balanced. Alright, now 13 take away 9 is 4. So here's the idea. The 9 is represented inside here. If I was to multiply that out, there would be a 9 there, and there it is right there. But I want to make sure I still have 13 from the original function. So again, I'm going to change colors here. The idea is that we fill in the third piece to complete the square, but we need to subtract or do the opposite. Okay? In other words, again, I'm going to add 9 and I'm going to subtract 9 on the same side of the equation, which effectively is adding 0. I have not changed the function, I've just changed the way it looks. Alright, let's move on. After I've completed the square, I notice that right here in this location, that's the h value. In other words, that's the x value of the vertex. So we know it's going to be at positive 3. And this part here is the k value. Remember that we usually think of it as h comma k. In most textbooks you'll see that notation. So knowing that the vertex is 3 comma 4, from the origin I go over to the right 3 and up 4. Then everything else is symmetrical about that point, because remember it comes from the parent function. So as I showed in the previous screen, you're going to go over 1 up 1, over 2 up 4, and over 3 up 9. Make it symmetrical about the vertex, and you'll see it right here. Let's go ahead and graph this. Alright, using the gray color to match our original function. So that's what the graph of that function looks like. We have shifted it from the origin over 3 up 4 because we put the original function in vertex form by completing the square. Let's look at example 2. So I have x squared minus 8x plus 10. Again, I'm looking to complete the square, so I'm going to create a little gap in here. And I need to figure out what goes in that third position to make this a complete square. So 8x squared, or excuse me, x squared minus 8x, take half of the 8, that's 4, and then square it. So to make this a perfect square trinomial, I'm going to need to add a 16. But if I add 16, I need to subtract 16. All in the same side of the equation to keep it balanced. Effectively, I have just added 0. Okay, this last part is a part that sometimes gets confusing for students. So let's rewrite this in Vertex form. So now I would have y equals x minus 4 quantity squared, because that's this trinomial factored out in perfect square form. And over here I have a negative 16, a positive 10, which would be a negative 6. All right, or I could say just subtract 6. Now that tells me that the vertex is at 4, negative 6. So from the origin, let's see where it shifted. It shifted to the right 4 and down 6. Again, it's a symmetrical parabola, so from the vertex I'm going to go over 1, up 1, over 2, up 4, and over 3, up 9. Make it symmetrical about the vertex. And you can see we're getting a little faster with this. And now let's graph it. So from the original function, x squared minus 8x plus 10, I completed the square. I had to add 16 and subtract 16 at the same time. You factor it into its vertex form, and that tells us our vertex was 4, negative 6. All right, one last example. If you'd like to try this on paper, you should pause this video right now and then come back and let's see if you're right. So remember that we moved the third term over to create some room here so we can complete the square. So x squared plus 6x, if it is truly, well, an easy example of how to complete the perfect square trinomial, you take half of the x term, so that would be 3x, square the 3 to make 9. So we're going to add 9, but don't forget to subtract 9 on the same side of the equation. So again, we're adding 0, but we're splitting it up so we can create a perfect square trinomial right here. So now we would have y equals, think about how to factor that. All right, that's got to be x plus 3 quantity squared, and notice 11 take away 9 would be 2, so it would be a positive 2. All right. So our vertex can be pulled from this information here. Now again, we are looking at minus a negative 3. Okay, that's how the plus 3 gets there. So we know that our vertex has to have an x-coordinate of negative 3. Be careful about that sign there. And this just is the same sign here, positive 2. So negative 3, positive 2, that's what the vertex of our new parabola is. And then from there we go over 1, up 1. Over 2, up 4, and over 3, up 9. Symmetrical about the vertex. And let's graph it. So if you see a trinomial and you're trying to complete the square, you want to make sure you do it correctly so that you find the vertex and then plot the points from there. Hope these examples have worked well for you, and I wish you luck in what you're studying. Again, have your parents go to my website, fill out the information, request for more tutoring, or give me a call on my toll-free number. Thanks for watching. Take care. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live, online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard and take care.